equation part 2, and here we will do two important concepts when the search root occurs in pairs and another is the Rolle's theorem. So we'll state some basic facts, then we'll continue. Uh, so here the first fact, first recall one. If an equation with real, if an equation with rational coefficient with rational coefficient has third root, alpha plus root beta, where alpha beta are rational and beta is not perfect square. Alpha beta belongs to Q and beta is not a perfect square, then it has also the conjugate third root, then it has also a conjugate third root, alpha minus root beta. That means, in other words, we can say in an equation with a rational coefficient, in an equation, algebraic equation with a rational coefficient, third root occur in conjugate pair. Third root occurs in conjugate pairs. That means in an equation with rational coefficient, if 2 plus root 3 is a root, then 2 minus root 3 is also a root. So alpha plus root beta and alpha minus root beta, where alpha and beta are rational and beta is not a perfect square. So beta is not 1 square or 2 square or 3 square. In that case, this pair is called the conjugate third roots pair. So this is conjugate third roots pair. Okay. So that means here we can deduce one important note. In an algebraic equation with a rational coefficient, that means coefficient belongs to Q, the number of third root is always even. The number of third roots is always even. That is, if fx equals to summation AIXI, I equals to 0 to n, belongs to Qx, that is coefficient is rational, then the number number of shared roots is always even. Why it is even? Because the shared root occurs in conjugate pairs. As shared root occurs in conjugate pairs. Okay, so this note is very, very important. Now we will solve one problem based on this recall. So here the question, very, very important. The question is, solve the equation x to the power 4 plus 2x cube minus 16x square plus minus 22x plus 7 equals to 0, which has root 2 plus root 3. So obviously here you just observe this is a algebraic equation with a real coefficient, and also it has a third root. So you know the third root occurs in conjugate pairs. Third root occurs in conjugate pairs. So 2 minus root 3 is also a root, because 2 and 3 are rational number. 3 is not a perfect square. So it occurs in conjugate pairs. So here we just let fx equals to x to the power 4 plus 2x cube minus 16x square minus 22x plus 7. Since fx belongs to qx, that means coefficients are all rational, and 2 minus root 3 is a root, 2 plus root 3 is a root. That root is basically third root. So by the above recall, 2 plus root 3 is the root. So there is another root. This is 2 minus root 3. So we can say 2 minus root 3 is also a root of 1. So therefore, we know if alpha is a root, if alpha is a root of fx, that implies x minus alpha is a factor of fx. Therefore, we can say x minus 2 plus root 3. This is a factor. Even x minus 2 minus root 3, that product is a factor of fx. That means x square minus 4x plus 1 is a factor of fx equals to x to the power 4 plus 2x cube minus 16 square minus 22x plus 7. Since x minus 2 minus root 3 multiple x minus 2 plus root 3. This is basically x square minus 4x plus 1. So, therefore, by division algorithm, for polynomial, we say that fx equals to x square minus 4x plus 1 into some qx. So here fx, if we divide by, because it is a factor, so here the remainder is 0 and quotient is qx. Now you apply division algorithm. So now we need to decide what is our qx. Then qx equals to fx by x square minus 4x plus 1. That implies qx equals to what is our fx? Our fx is x to the power 4 plus 2x cube minus 16x square minus 22x plus 7 by x square minus 4x plus 1. That implies qx equals to x square, because it is a factor. So multiple of something by x square minus 4x. Now you will see that will be, if we just multiply by x square into x square is x to the power 4 minus 4x cube, we need 2x cube. So this is 6x, then 7. So what is qx? Qx is x square plus 6x plus 7. So this is also another factor. So now you will do qx equals to 0. That means x square plus 6x plus 7 equals to 0. That means we apply Sigar-Acharya formula. So minus b plus minus b square minus 4ac by 2. So this will be minus 3 plus minus root 2. So therefore, the solution is done. The roots of the equation x to the power 4 plus 2x cube minus 16x square minus 22x plus 7 equals to 0 are, what is given here? 2 plus root 3. And we said this is a third root, so it occurs in conjugate pair. So 2 minus root 3 is also a root. Here by solving, we have another 2 root, minus 2 plus root 2 and minus 3 minus root 2. So these are the 4 roots. The equation is a degree 4, so it has a 4 roots and no more. So this is our answer. Now we come to another important recall. Or you can say the theorem. The theorem says that let fx be a polynomial with real coefficient. That means fx belongs to Rx, polynomial with real coefficient. and if alpha comma beta be two distinct real root are and alpha not equals to beta, distinct real numbers, such that f alpha and f beta are of opposite sign. So that means f alpha into f beta less than 0. What exactly mean? They are opposite sign. That is f alpha and f beta are of opposite sign. Then the equation fx equals to 0, the algebraic equation fx equals to 0 has at least one real root, has at least one real root lying between alpha and beta. Lying between alpha and beta. So here fx is one kind of polynomial function, that means it is continuous. And alpha and beta are basically two real numbers. So if alpha f beta opposite sign, that means it is like this. This is your f alpha greater than 0. This is your f beta less than 0. So f alpha, f beta is negative. So there exists a root between alpha and lying between alpha and beta. We just considering the root is some delta, where here you will see f of delta equals to 0. But here note, if we see fx keeps the same sign, if fx keeps the same sign for all real values of x, for all x belongs to R, then fx equals to 0 has no real root and conversely. It is quite obvious. This is a real line and fx is maintain the same sign always. So obviously it does not cut the x-axis. So that means it has no real root. Now we come to the important problem based on this result. Show that the equation x cube plus 2x square minus 2x minus 1 equals to 0 has one positive root and one negative root and two negative root. One lies between -1, 3, 1, lies between -3 and -1, and other negative root, another lying between -1 and 0. How to solve this kind of problem? Let just give a name. Fx equals to x cube plus 2x square minus 2x minus 1. Now what is set? In a real line, this is 0. It has one positive root. So one root is here between 0 to infinity, and two negative root. One lies between -3 to -1. So this is -1 and this is -3. So a negative root lies between this interval and the other lying between -1, 0. That we need to show. So we'll calculate then f of infinity, take however large number tending to infinity. So obviously this value greater than 0, and you take f of 0. This is basically -1 less than 0. So here f of alpha, this is alpha in sense of infinity. Alpha is however large, this is greater than 0, and f0 is negative. That means product is basically of less than 0. Then we can say fx equals to 0, 0 has at least one positive root, has at least one positive root, or you can say one root must be belongs to 0 to infinity. Now we will calculate again. You calculate f0 is negative, f of -1. So f of -1, this is -1 whole cube, 2 into -1 whole square, 2 into -1 plus 2 plus 2 minus 1. So this is 2 greater than 0. We have already seen f of 0 less than 0. So that means in -1 and 0, the functional value is opposite. So that means f of -1 into f of 0 less than 0. That implies fx equals to 0 has a root lying between -1 and 0. So that means, therefore, there is at least one root, one negative root lying between -1 and 0. Again, you calculate f of -3, that means -3 whole cube plus 2 into -3 whole square, 2 into -3 plus 1. And you will see this value, that is -27 plus 18 plus 6 plus 1. This is equals to -2 and less than. whereas f of minus 1 is greater than 0. We already seen f of minus 1 equals to 2 and it is greater than 0. That means f of minus 3 into f of minus 1, negative, that they are opposite sign. That means fx equals to 0 has a root, has at least one root lying between minus 3 and minus. So therefore, there is at least one negative root lying between minus 3 and minus. So we have the equation, the degree of the equation is 3 and we have got 3 root. One lies between, one is positive, others two negative real root. One lying between minus 1, 0 and other lying between minus 3 and minus 1. So we can conclude, since a degree of fx equals to 3, so the equation has exactly three roots. One root is positive, one root lying between minus 1 and 0, and another negative root lying between minus 3 and minus 1. So this is our answer. Next we move another important problem. Okay, this question asks as a MCQ type question. Let fx equals to x cube plus 2x square minus 2x minus 1 equals to 0. Then which of the following is or are true? Option A, fx equals to 0 has 3 positive root. Option B, fx equals to 0 has 2 positive root and 1 negative root. Option C, it has 2 negative roots and 1 positive root. Option D, all roots are not real. So obviously the equation has degree 3, that means odd degree. So it must have, you will see, the degree of fx equals to 3, which is odd. So that means fx belongs to Rx has a real root. So option D is false, as we use the fact every odd degree polynomial with a real coefficient must have a real root. Real root. Option D is false. And here, with the previous problem, you will see we got two negative real root. One lies between -3, -1, other lies between -1, 0, and one positive. So number of positive root is 1 and negative root is 2. Option C is correct and all other options are false. So in that way you have asked the MCQ type question. Now we come to the next problem. Problem number 2. This is very, very important. Show that for real values of lambda, the equation x plus 3 multiple x plus 1 multiple x minus 2 multiple x minus 4 plus some lambda into x plus 2 x minus 1 x minus 3 equals to 0 has all its roots real and simple. Real and simple. Simple, that means root of order 1. That means the root occurs 1 times. There is no multiple root. And all roots must be real. Now we come to the solution. So what is fx here? Here fx equals to, let fx be x plus 3 into x plus 1 into x minus 2 into x minus 4 plus lambda into x plus 2 into x minus 1 into minus 3. So this is given. And here you just observe the term which is associated with the lambda. Lambda সাথে এটা associated আছে. Just observe that part. And you will decide where this part has 0 on the real line. So it has 0 at 1, 3 and minus 2. So these are the 3 important points that plays an important role. Because when if you put x equals to 1, so lambda has no role. X equals to minus 2, lambda has no role. Because that part will be 0. So then we see that f of infinity, this is strictly greater than 0. What is f of minus 2? So this part is vanish. We just put x equals to minus 2 here. So that is minus 2 plus 1. That means minus 1 at minus 2 point minus 1 multiple f of minus 2. So this is also minus, this is 1. This is minus 1. Minus 2, that will be minus 4 and that will be minus 6. So it will be negative. Therefore minus 2 is negative because 3 minus sign here. Next you will think about f of 1. F of 1, you will see this is positive. Just put the value x equals to 1 in fx. And again you will check f of 3 that point. So here positive, negative, here positive, f of 3 again negative, you will check it. And f of minus infinity, this is also greater than 0 because equation, because why it is greater than 0, since degree of fx is 4, x to the power 4 is present, plus symbol is there. So that is tending to infinity as x tending to minus infinity. So these are the observations. So therefore, just first you will think the interval minus infinity to minus 2. That interval, this multiplication is negative. So minus infinity to minus 2. So here I have minus infinity, here plus infinity. So minus infinity to minus 2, the product is negative. That means it contains a real root. And here this product f minus 2 f1 is negative. That means it contains a root. This contains a root 1 to 3, and 3 to infinity is also contained because they are opposite sign. So therefore each intervals minus infinity to minus 2, that interval, next minus 2 to 1, next 1 to 2, 1 to 3, and after that 3 to infinity contains at least one real root, contains at least one real root of the equation fx equals to 0. Now since what is the degree of fx? This is equals to 4, and it has 4 real root. One lies between minus infinity to minus 2, other lies between minus 2 to 1, 1 to 3 and 3 and infinity. Here one real root, here is also one real root, here is also one real root. So here you will see 4 root already there. So since degree of fx equals to 4, so we can conclude that all its roots are real and simple. So we put this problem. So here you have asked this kind of question as a one option correct. And that question has been asked in any competitive examination. Question: for what values of lambda the equation x plus 3 into x plus 1 into x minus 2 into x minus 4 plus lambda into x plus 2 x minus 1 into x minus 3 equals to 0 has all its roots real and simple. Option A, for lambda only for lambda greater than 0, only for lambda equals to 0, only for lambda less than 0, or for all lambda belongs to real number. So we have checked for all lambda belongs to real number, all the roots are real and simple, so option D is correct. All other options are false. So here the roots are real or simple, whatever lambda may be. Now we come to the important theorem. This is called the Rolle's theorem. So the statement of the Rolle's theorem. Let fx be a polynomial with real coefficient. So fx belongs to Rx, be a polynomial. Then between any two consecutive roots, between two consecutive roots, real roots of the equation fx equals to 0, there is at least one real root of the equation f dash x equals to 0. Okay, so that means you will see here fx is a polynomial and two consecutive roots like this. So two consecutive roots, that means it cuts x-axis at least 2 points. You just consider this is alpha and this is beta. You just think about that point, what is the slope? The slope is basically parallel to x-axis. That means at that point, just we consider is delta. So f dash delta is equals to 0. That means delta is a root of f dash x equals to 0. So this is basically Rolle's theorem. And with the help of Rolle's theorem, we can we can solve many kinds of problems. We can find out the roots of f dash x equals to 0. There is another important recall, that is based on the Rolle's theorem. What is this? Between two consecutive roots, alpha dash beta dash of the equation f dash x equals to 0, that is initially said in the Rolle's theorem consecutive root of fx equals to 0. Now we are thinking consecutive roots of f dash x equals to 0. What is the conclusion? There is no real root, or at most one real root of the equation fx equals to 0. And if root exists, such a root must be simple, that means it occurs one times. And such a root, if root exists, must be simple root. Must be simple. That means it occurs exactly one times. If it occurs. Another important recall that comes as a corollary of Rolle's theorem. If all the roots of the equation fx equals to 0 be real and distinct, be real and distinct. This is very, very important. Real and distinct. That means all are basically simple roots. Then all the roots of f dash x equals to 0 are also so. That means it also, if the roots of fx equals to 0 real and distinct, that means simple roots. So the roots of f dash x is equals to 0, that is also real and distinct. With the help of previous corollary and Rolle's theorem. And here we can say continuation. Furthermore, any two consecutive roots, in that case, consecutive roots of f dash x equals to 0 are separated by the roots of fx equals to 0. Next we come to another important result. Recall. So that will be recall 6. Let fx be a real polynomial of real coefficient. Be a polynomial if the equation fx equals to 0 has r real roots, that means number of real roots is r, then the number of real root, then the number of real roots of the equation f dash x equals to 0 is at least r minus 1. At least r minus 1. Okay, here you will see, because between any two consecutive real root of fx equals to 0, there exists at least one real root of f dash x equals to 0. That's why at least r minus 1. Now we come to one important problem. So before that, there is one important note. If all the roots of fx equals to 0 be real, then the equation f dash x equals to 0 cannot have an imaginary root. Cannot have an imaginary root. So all the recalls you can prove. This is your self exercise. But okay, we'll solve one important problem. The problem asked in many competitive examination, even in B.Sc course. Show that the equation x minus a whole cube plus x minus b whole cube plus x minus c whole cube plus x minus d whole cube equals to 0, where a, b, c, d all are positive real number, not all equal, has only one real root, has only one real root. So this is one of the most important problem in the theory of equation. That problem has been asked in many examinations. So what is the solution? So first we consider this equation as fx equals to 0. So fx equals to x minus a whole cube, x minus b whole cube, x minus c whole cube, x minus d whole cube equals to 0, where all a, b, c, d are positive real number and not all equal. We can't say equals to b equals to c equals to d. This is equation number 1. Since the degree is 3, so this is an odd number. So it must have at least one real root, or you can say it has either only one real root or 3 real roots. Since degree of fx equals to 3, this is odd, so it must have at least one real root. We can say, so it has either only one real root or 3 real root. 3 real root. Why not 2? If 2 roots are real, degree is 3, so that is another root that is imaginary. But imaginary root occurs in conjugate pairs. So that means in that case number of roots will be 4. That is not possible because number of roots cannot exceed the degree. So obviously there are two possibilities, either exactly one real root or 3 real root. So here the degree is odd, that's why real root must be there. Now we assume that we need to show only one real root, but there is a possibility 3 real root. So we need to discard this possibility with the help of logical argument. So let us assume the equation has more than one real root. So let us assume that the equation fx equals to 0, that means that equation x minus a whole cube, x minus b whole cube, x minus c whole cube, plus minus d whole cube equals to 0. has more than one real root. That means we are talking about three real roots here. This is the other possibility. So we consider let alpha comma beta belongs to R, B to such. The alpha beta are the real root of fx equals to 0. So then what we say? Then we say f dash x equals to 0 has a real root between alpha and beta. Has a real root between alpha and beta. Why we say that? Because you say if it's a polynomial of the equation fx equals to 0 has r real roots, then the number of real root of the equation f dash x equals to 0 is at least r minus 1. That means fx has two real root we consider, so at least 2 minus 1. That means one real root must exist of f dash x equals to 0 with the help of last corollary. Now what is f dash x? Now our f dash x equals to 3 into x minus a whole square, 3 into x minus b whole square, 3 into x minus c whole square, 3 into x minus d square. So that means it will be 12x square minus 6 a plus b plus c plus dx plus 3 into a square plus b square plus c square plus d square by the simple calculation. Now the question, what is the discriminant of f dash x equals to 0? So therefore the discriminant of f dash x equals to 0 is b square minus 4ac. So what is b here? Minus 6 into a plus b plus c plus d, that whole square, minus 4 a means 12, c means 3 into a square plus b square plus c square plus d square. So what is this value? This is 36 a plus b plus c plus d, that whole square minus 144 a square plus b square plus c square plus d square. Now since a, b, c, d are all positive real number, again since a, b, c, d all are positive real number, not all equal. So with the help of image power theorem, for m equals to 2, we can say a square plus b square plus c square plus d square by 4. This is greater than a plus b plus c plus d by 4 their whole square. So that means 4 into a square plus b square plus c square plus d square. This is greater than a plus b plus c plus d whole square. So therefore, with the help of this we just can star and double star. from star and double star, we can say the discriminant of f dash x is negative. So therefore, from we say that the discriminant of f dash x equals to 0 is negative. Why negative? Because if we multiple it by 9, so 36 square plus b square plus c square plus d square greater than 9 into a plus b plus c plus d whole square, or you just multiply the 36 both sides. You will see 36 a plus b plus c plus d whole square less than this quantity. So obviously this quantity must be negative. So discriminant of f dash is negative, and so f dash x equals to 0 has no real root. What is the fact here? The fact is, if x square plus bx plus c, this is your quadratic equation of degree 2, and discriminant, that means b square minus 4ac, this is less than 0. That implies this equation x square plus bx plus c equals to 0 has no real root. That means all roots are complete. Similarly, f dash x equals to 0 has no real root. And here we have seen f dash x equals to 0 are real root between alpha and beta. So this is a contradiction. So which contradicts. So if I say this is 1, so which contradicts, or 2, so which contradicts 2. So that means our assumption is false. Our assumption was the equation fx equals to 0 has more than one real root. This is not true. So that means the equation fx equals to 0 has only one real root. As there is two possibility, either exactly one root or 3 real root. If we assume 3 real root, then we arrive at a contradiction. That means we need to agree. We must agree with the statement fx equals to 0 has only one real root.